Hey, so we're gonna solve this integral right here. So we have a fraction and we have up here a binomial to the square. And unfortunately, nothing would work this way. So what I would suggest here is to try discomposing or unfolding this binomial, because probably we would have a more flexible way to resolving the problem. So let's do it first, okay? So we know that this, obviously, we're gonna multiply this times this, then actually we're gonna multiply this times this, and this times this 2 times. All right, so it's gonna be pretty simple. So we're gonna have the integral of a root squared to the power 2, and then we're gonna multiply this times this, right? 2 times. Remember, this is done 2 times, so we're gonna add the 2 over here, and we're gonna have a minus sign because we have a minus sign over here. And finally, we're gonna have this x square rooted to the power 2, and this is going to be plus. There we have it, and this is all divided by the square root of x. Perfect. So now obviously we know that by having this square root and having the power 2, we can eliminate those, right? So we get rid of this and this, and we're gonna have over here, we're gonna have the integral of a minus 2 times this times this plus x. All right, and this is all divided by x. And if you know basic algebra, you should know that since we have 3 terms over here, each term can be separated into a single term. Well, actually, if like this, this is a one single term, right? So if you want to split this up into 3 terms, which are the ones that are inside this whole term, we can simply use the denominator over here and put it down of each of the terms. So let me show you what I'm talking about. So in this case, this would be the same as having, by the way, I'm forgetting the dx. So let's put the dx over here. So this is going to be the same as having a over the root square of x minus 2 times a times x over the square root of x plus x over the square root of x, right? So this is the same as this because we have the denominator, we have the same denominator in each one of the terms. So now what? This is much easier to use to integrating the problem. So we know that this is the same as, let me put it down here. Let me move a little bit down here. So this is going to be the same as having, let me jump to, yeah, so this is the same as having alright, this is supposed to be an arrow or whatever. So yeah, it's very, there we go, this looks better. So this is the same as having the integral of each one of these, right? So we will have the integral of a over this minus the integral of the second term, which is this, divided by the same denominator plus the last integral, which is the last term, dx. All right. So this is the same. And this is using this simple rule that I got here. Okay. This is done by using this simple rule. And now, as you can see, we can get the integral of each one of these terms much easier. So let's go ahead and try it out, okay? Each one of these terms are much easier to resolve. So we're gonna do each one of them, okay? So let me just zoom out a little bit, and we're gonna do the first one. Okay, so the first one, I'm gonna label it as the red one. So this is going to be the red one. We're gonna get the integral of a divided by this. So how we're gonna get the integral? Pretty easy. We know that this is the same. I put it outside the constant, and we're obviously put it outside the constant. We're gonna leave a 1 here because we are gonna still have this x over here, right? And we can manipulate with using the radical rule. So we know that the square root of x is the same as having x to the power 1/2, right? And this is obviously wrong. Okay, there we go. And now, as we can see, we can move this up here, the x, and we would have a times the integral of x to the minus 1/2. So this is a simple radical rule that if you don't know what I'm talking about here, you should get a radical rules sheet. Okay, that is a mandatory thing for calculus. So I have applied all to this point, from this point to this point. Well, actually, from this point to this point, I have applied a bunch only radical rules. And obviously, there's a dx here, right? So as you can see now, we have u here, we have n, and we have du. All right. You should know what I'm talking about by this point, because if you don't know, you should go to more simpler integrals prior getting to this part. Why? Because I'm obviously using the most powerful rule, which is this one that I'm gonna put up here. It's the power rule. We got u, we got n, we got du. Now let's apply the rule. So the rule says that this is going to this is going to be the same as having u, which is x, and don't forget the constant that we left outside the integral. So let's put a, multiplying x to the n plus 1. So it's going to be minus 1/2 plus 1. That is obviously 1/2. And we're going to divide it by the same 1/2. There we have it. Now, let's simplify. And this is going to give us a. Actually, this 2 is going to go up here. This is a simple algebra rule. If you don't know what I'm talking about, you should go to high school. And to a, multiplying the x, and this is our final result. And to make it even cleaner, we should write down 2a multiplying the square root of x plus c. So this is the first integral out of 3. All right, so now let's go with the blue, which is, I'm gonna label the second one. So let's do the blue. All right, I'm gonna put it down here. So the blue is going to be 2 multiplying the square root of a and the square root of x. Sorry. Everything divided by the square root of x. So obviously this is pretty simple. We see here that we have 2 square roots here. This is multiplying, this is dividing. Simple rule, we eliminate them. So we're gonna get rid of those. And we're gonna be left with the integral of 2 times the square root of a. Now at this point, by the way, I'm missing here dx and dx. By this point, we should know that all we gotta do is remove this d right here. Right? This is the simplest rule in calculus. If you're not sure of what I'm doing here, you should review your calculus sheet. Now the final problem, which I'm gonna label as the green problem, I'm gonna do it over here. So this is the green problem. We're gonna get the integral of x being divided by the square root of x. Okay, so this is going to be equal to having x multiplying x, all right, minus 1/2. Why? Because we're using the radical rule that we have already used tons of times. So I highly recommend you to get that radicals sheet. All right, and we know that whenever we know that we have here an imaginary, well, it's not imaginary, but it's not visible 1. So whenever we multiply 2 similar terms, all we gotta do is sum or rest up the exponents. So in this case, 1 minus 1/2 is going to be x to the 1/2. Now we apply the power rule, and this is going to be nothing but x. By the way, I'm forgetting here. I'm forgetting all the way to put the x, which sometimes is just, a lot of time that it takes. That is why sometimes you don't put the dx, but the dx is all the way until we use the integral rule. So in this case, we're using the power rule. We're gonna get 3 halves divided by 3 halves. And this is the same as having 2x 3 halves divided by 3. And to put it cleaner, this is the same as having 2 square root of x 3. There we have it, buds. So this is the answer, plus c. All right, and now all we gotta do is add up all the answers that we got here. So getting to the main problem, this is not hard, but it takes a lot of time. That is why but it's not difficult at all. So now we're just going to add each one of the integrals, right? So we know that this is equal to all the results that we got. Okay, so the first result is the red one. So let's write down the red one. 2a 2a times x minus the integral of the blue one, which is 2 times x plus the integral of the green one. It's going to be this, and this is the final answer. Okay, don't forget the 3 that is dividing this whole term. So the final answer is this. So you have a good day.